Now what I would like you to do is to look at a table that I am going to show you. Okay, so this is a table, and for each of these circles it may be a little bit difficult for you to see on the screen, but once you look at the notes you will be able to get an idea of what it is. Now for each of these there are 1, 2, 3, 4, 5, 6, 7 cases. Okay, so total of 7 cases. For each of the 7 cases we would like you to write down the ROC. Write down the ROC that is indicated. The shaded portion is the ROC. Okay, and once you have done that, I would like you to specify or indicate whether the ROC represents a sequence that is causal and whether the sequence is bibostable. Okay, ROC represents a sequence that is, number one, whether it is a causal sequence, and second, whether it is bibostable. Okay, so let's take a quick example, this thing. So case 1, you have the unit circle which is always a solid line, and then the region of convergence starts at some r which is less than the unit circle. So the ROC we can specify as mod z greater than r, where r is between 0 and 1. Okay, so then we look at the since it's a right-sided sequence, we can say that it is causal. You can say that this ROC represents a sequence that is causal, and because it includes the unit circle, we can also say that the sequence that it represents will also be bibostable. Okay, so that is a type of expressions that I would like you to be able to write down for each of these. Okay, now look at this second ROC. The second ROC is a actually there is a small mistake here. This is mod z equal to 1. This is some value of r mod z greater than r, where r is greater than 1. Okay, so the inner circle, the solid line is the unit circle. This is a circle which is, so this is a right-sided sequence, so it will be a sequence that is causal, but it does not include the unit circle. Unit circle is not in the region of convergence, so therefore this will be not bibostable. You will not have the DTFT. That's another way of saying the Z transform exists, but the DTFT does not exist. Okay, so in other words, it's a bibo unstable system. Okay, let's quickly write down. I will leave you to write down the interpretations. In this case, it is mod Z less than R, where R is greater than 1. Okay, R is greater than 1. So you can see that this will be a anticausal or left-sided anticausal sequence, and it will be a stable system, includes the unit circle. Okay, number 4, look at the sequence. It is anticausal and not bibostable. Not bibostable. Okay, so this is 1, 2, 3, 4, almost there. Number 5, mod Z is greater than R1, less than R2, and these are including the unit circle. So therefore this is a two-sided sequence, and it is bibostable. Okay, and you can see that this is number 5, number 6 and number 7. Number 6 and 7, I will combine them like this. They are both two-sided. both do not include the unit circle, therefore they will be bibo unstable. Okay, or DTFT will not exist. Okay, so again, the ROC tells us a lot of information about the sequence, and in fact, without you have to get the ROC correct in order to be able to make a statement about the actual the Z transform that is there. Okay, now here is another example that will sort of emphasize the concepts that we have been looking at. One more example that I would like you to consider. Okay, we are given that x of n is absolutely summable. Absolutely summable. Okay, what does that mean? Mod z, if you take the sum of the modulus, that is a finite value. That means it's absolutely summable, means the DTFT will converge uniformly. When it comes to the context of the Z transform, this is another way of saying that the ROC includes the unit circle. Okay, and this is x of n is absolutely summable signal with a rational Z transform. That means numerator denominator. Rational Z transform x of z with a pole at z equal to 1/2. Okay. Now, I hope you are able to visualize what type of sequence we are talking about. Okay, the first question, can x of n be of finite duration? Can it be a finite duration sequence? What would you say? We go back and look at the properties. A finite duration sequence will have region of convergence, the entire z plane except possibly z equal to 0, z equal to infinity. Otherwise, all the entire z plane should be allowed. But we have a pole at z equal to 1/2. Okay, this x of z has a pole at z equal to 1/2. So ROC cannot be equal to entire z plane. Okay, if this is not true, then this means that it is not a finite duration sequence, not a finite duration sequence. Okay, so this is a application of basically looking at it from different directions. Okay. Second question. Can x of n be a left-sided sequence? Left-sided sequence. Okay, where is the pole? Z equal to 1/2. Can the ROC be defined as mod z less than 1/2? Yes, of course, it can be defined as as less than 1/2. However, if you define mod z less than 1/2, is the unit circle included or not? Not included. But we know from the first statement that that this is absolutely summable. Okay, absolutely summable signal, which means that the DTFT exists. DTFT exists. So left-sided sequence means DTFT. So basically, it will be mod z less than 1/2. Okay, but we know that ROC from given condition is that ROC includes unit circle. Includes the unit circle. So we reject this also by saying first one is no, second one is no. Okay, third part, can x of n be a right-sided sequence? Be a right-sided sequence? Answer is yes. It can be, it can include the region of convergence, could include. So a right-sided sequence. So for example, mod z greater than half, this is perfectly allowed. So this is a yes for this sequence. Okay. Now the last question, can x of n be two-sided? So basically it is mod z greater than 1/2 but less than some value on the right hand side. So we are looking at a situation where mod z greater than 1/2 less than RL. That means there is another pole which is there, which is not excluded, because we know, all we know is that there is one pole at z equal to 1/2. So this is a possibly yes. Right? We don't know, we don't have all the information, but if you have to give an answer, it is possible that it can be two-sided, because you can have another pole which will be limiting the sequence. So therefore it will be a two-sided sequence. So basically a left-sided component and a right-sided component. Okay, so this is a good place for us to say, I think we are comfortable with ROC, what are some of the implications, what are some of the properties, and then we can look at how we can apply these things in our study. Let me give you a few examples for you to work out more by way of exercises. So these are exercises that I would like you to try out. So given that x of n, first one, x of n is equal to 1/2 raised to the power n plus 1 u of n plus 1. Okay, very important. This is a shift in the sequence. I want you to show that the ROC is mod z greater than 1/2, but z equal to infinity will get excluded. Okay. You need to please carefully look at it and show that this is indeed the case. Okay, second example. We are given x of z, okay, equal to summation n equal to 1 to infinity 1/2 of minus n plus 1 z power n. Okay, we are given the expression for x of z. Obtain the ROC. What is the, basically it's a geometric series. You show what is the condition for the convergence, and in this particular case obtain the ROC, which will be mod z less than 1/2. They basically, though this looks like a right-sided sequence, it actually is a left-sided sequence, which has been simplified to get this particular expression for the ROC. Okay, third example. X of n is equal to minus 1/2 raised to the power n u of minus n minus 1 plus 2 power n u of minus n minus 1. Okay, what is the ROC? Basically there are two terms, both are left-sided sequences, so therefore you would have to look at the intersection of that, show that the region of convergence, we have to take the intersection of the two, and the intersection of the two will be mod z less than 1/2. Okay, and this is also something that you should be able to do without too much of difficulty.